Hey Yannik, I'm so excited to interview you today. I'm a big fan of Arcium. It's nerd sniped me, as I'm sure it's nerd sniped a lot of developers, a lot of people in the ecosystem. Been learning a lot about it. I figured before we get too deep into it, maybe a round of introductions between me and you, just so the audience knows who we are. You want to go ahead?
Sure. Yeah, thanks for having me. And I'm Yannik, the encrypted CEO of privacy at Arcium. And yeah, you can tell that it's me because I'm wearing purple clothing.
Yeah, but I can see your face. It's not. It's not.
It's not encrypted.
It's not encrypted.
That's happening soon.
Okay.
I'm working on that.
Nice. And I'm Dev. I'm co-founder of Seedplex, which is a team here at the Solana Labs Incubator. And we're going to be building on Arcium. We work on building a new type of token standard that helps founders raise through the best of equity and token fundraising. And one of the feedback that we got was this is way better done if it was done in an encrypted format, which is what got me down the Arcium rabbit hole. Cool. So let's jump into the questions straight away. First, what is Arcium? I'm sure everyone's heard these terms. You know, like it's been a buzzword. In like just one sentence, what is Arcium? Why should people care?
Arcium is the encrypted execution engine of the internet. And what that means is that Arcium allows all information and data to interact and travel at the speed of light while being fully encrypted. Nobody sees anything. Everybody gets the benefits of the information and data collectively.
So how is this different than what Solana already does?
So Solana is a global execution engine, a global public execution engine, if you will, right? And so what Arcium is Arcium connects everything and enables it to be encrypted. What that means specifically on the connection between Arcium and Solana is that what Arcium adds to Solana is encrypted execution. So that means that within your on-chain programs, you can not just have public shared state, which is this great unlock that Solana brings, right? A single ledger, shared state, everybody interacts on this one global ledger. But with Arcium, we now have encrypted shared state also on this ledger. And that's this powerful unlock where we can have public and private execution.
That sounds amazing. We'll deep dive into what that design space is. Before we get there, let's talk about what are the kinds of teams that are currently nerd sniped by Arcium, right? So we saw the Umbra ICO do numbers. Can you talk about some other teams that we might see coming up? What are you most personally excited about, the teams that might be building on Arcium next?
Yeah, so I think what's so interesting about this design space that we're opening up is that you have teams like Umbra, which you immediately can connect with what we're doing, right? Because what Umbra says they're doing is building the incognito mode for Solana. And Arcium is this encrypted execution engine. So it makes sense, right? Because Arcium is privacy, private computing. But what we're doing essentially at the end of the day is changing how computing works. We're changing computing from public computing, having to trust whoever computes, to encrypted computing. And that enables so many more use cases. So I think what's especially interesting is us working together with Mealy, the permissionless prediction markets on Solana, for example, where Arcium is being utilized for encrypted oracle voting and then encrypted oracle resolution so that you don't see the votes of oracles in those permissionless markets upfront, right? So those are the vast applications that we have. We also have teams on top of Solana building encrypted machine learning with Arcium. And so you could literally not imagine these kinds of use cases previously, but with Arcium they become possible. And they're not just privacy-related use cases. It is really a new form of computing that unlocks more powerful applications.
Yeah, that is the thing that excited me the most. You know, privacy is a buzzword that a lot of people are excited about. Again, it's not just a buzzword, it's a real thing. But privacy for the sake of privacy, I think, is only one avenue in which Arcium really connects.
Yeah.
The thing as a developer is this is an entirely new design space. There's so many more cool things I can build because I have confidential compute, I have confidential encryption, and or confidential storage. This design space is absolutely massive. Going to privacy for a quick second, does Arcium make Solana now competitive in the same arena that things like Zcash or more top-of-mind privacy coins are doing?
Oh, it makes it way more competitive.
Okay.
Way more competitive. And so the evolution of privacy itself, I think, can be categorized into two categories. Privacy 1.0, which is legacy privacy, and privacy 2.0. And the big difference between both is that Privacy 1.0 operates over isolated encrypted state, and Privacy 2.0 operates over encrypted shared state. And so what Solana again brings is shared state, public shared state. And what these kinds of strictly ZK-based privacy approaches like Zcash bring is isolated encrypted state. So everybody has some secret, like their token balance, their token holdings, right? The history of their transactions, which is only accessible to them, which they essentially keep locally. At some point, they have something like a private key that gives access to all of that information. So they have that locally. And in order to interact in those Privacy 1.0 systems, they generate zero-knowledge proofs, which then, I guess, collapse the amount of information down to a single proof that is being verified on-chain. And that's nice and all. That gives a base level of privacy. But what it doesn't enable is encrypted application. It doesn't enable you to trade privately. It doesn't enable you to interact with everyone else's secrets in a private way. And that's what Privacy 2.0 does. With Privacy 2.0, we have the same modus operandi as shared state, but now in a secure and encrypted way. And that unlocks all of the new use cases. And so that's why that makes Solana more competitive, because now we have encrypted shared state, encrypted computing on-chain, and we also have this rapid public execution engine. And we can composably switch between both contexts and enable so many more applications.
Would you say that is, you brought up ZK as a technology. Would you say then Privacy 1.0 is zero knowledge or ZK, and then Privacy 2.0 is more MPC, the stuff that you guys are working on?
Yes, exactly. Yeah, and I mean, ZK is a powerful primitive, right? Arcium uses that as well. But for me, only utilizing ZK is a legacy approach, and so we need encrypted computing. And in those architectures, ZK mainly plays a role for things like verifiability. And of course, if you look at the way Arcium functions within different parts of the architecture, there are zero-knowledge proofs. But at the end of the day, it's a cryptographic primitive. And what matters most, and that's why it's also important to think about privacy the way you just described it with other privacy networks and privacy and other use cases that are being unlocked. Privacy 1.0 has been designed in a way that it has been designed because privacy has been thought of as a purely political thing. And the way I try to think about privacy is a new superior form of computing that enables better and bigger business use cases.
Yeah, that's awesome. Real quick, I just want to back up a little bit. Since we brought up ZK and MPC, the layperson probably doesn't know what these terms mean. Let's talk about the three kinds of buzzword encryption technologies that are out there. We have ZK, we have MPC, and then we have FHE, if I'm not mistaken.
Yeah.
Can we talk a little bit, just at a very high level, what are the differences? Why Arcium is an MPC network instead of a ZK network? And what are the trade-offs there? Just to bring everyone up to speed.
Yeah. So our journey as Arcium actually started with ZK. So 3.5 years ago, we were building Elusive on top of Solana. And back then, we were more or less building a Zcash on top of Solana, if you will, zero-knowledge proof based. And through that journey, we realized the limitations of that technology and then switched towards Arcium, this bigger vision of encrypted computing, and build our MPC protocol. Now, as I just said, the way that ZK works is I have a secret and I run a computation locally over that secret, which produces a zero-knowledge proof. Now, what that process of running this local computation and generating that proof does is mainly two things. It reduces the information that I communicate. I can keep my secret to myself, and I only send the proof to you. You verify the proof, and you're being convinced that I executed that computation correctly, right? And given some additional context, like some state that is stored on chain, you can verify it against that state, and you can be convinced that whatever statement I claim about that secret value that I have is true. And that's how zero-knowledge proofs are used within those systems to maintain privacy. At the same time, ZK is also used for compression, for scalability in different architectures, because again, someone runs a computation which generates this mathematical object that you can verify, and that means that I could, for example, run a complex computation and you only verify the output, which makes it way faster on your end, which then especially makes sense if there's some computational resource asymmetry in those systems. ZK itself is very powerful, but again, it forces us to operate in a mode of someone being the custodian of some secret information, and that secret information never being able to interact with any other secrets. And that's why encrypted computing is the holy grail of privacy and computing, because it allows us to compute over your secret. I can compute over your secret without knowing your secret. And that's so powerful, because what that then unlocks is encrypted shared state, where I can say, I now take the private information from Dev, from Yannik, and from everyone else in the Solana office, and I compute the average of those values. I do whatever computation I please without ever having to see any single bit of information. And that unlocks these new use cases. And so that's this big difference between ZK, MPC, and FHE. Now, MPC and FHE are two approaches that enable you to run these kinds of encrypted computations. And at the end of the day, most FHE architectures in practice rely on MPC because they need MPC in order to manage something like decryption keys. And the big reason why we chose MPC over FHE is that our Cerberus MPC protocol is multiple orders of magnitude more performant than state-of-the-art fully homomorphic encryption, is incredibly scalable, and we've only been spending 1 year building that so far.
That's awesome, and very excited to play with that. When we talk about privacy, the other thing that we mentioned was decentralized confidential compute, right? A DCC, as I saw in your docs that you guys call it. Can you talk to me a little bit about, apart from privacy, what are some interesting applications of confidential compute that maybe aren't necessarily about hiding information, but do create a new interesting design space?
Yeah. So that's a very outdated term, I think.
Okay. So
we talk about encrypted computing nowadays.
Okay, so encrypted computing.
Yeah. And so I think what's so interesting is that in crypto, you can really feel the need and power that arises from having encrypted shared state. At the same time, you can see the same thing in traditional industries like healthcare, where you have highly sensitive, let's say, patient data that sits in isolated data silos, and that data cannot be shared. Even if you wanted to share the data from a regulatory standpoint, you cannot share the data, which makes sort of sense, right? And so encrypted computing can overcome those issues because you never have to share the data, while you can compute over everyone's data. And so that's the way I think about data. I don't think about data in a way of, I need to hide data, data needs to be locked in a safe. The way I think about it is, data should be locked in a safe that allows us to securely utilize everyone's data without ever exiting the safe. And that's what encrypted computing is at the end of the day. And for crypto, that means being able to onboard way more traditional users, be it retail users or industry users, institutionals, because they can use those systems in a trustless way and get more powerful applications.
So I want to drop just slightly into the technical, maybe not a technical explanation, but there was a great example that I saw in your docs that I loved quite a bit, which was the piggy bank example. There's a group of people, they all have a piggy bank or a safe with amount of dollars in it. They want to figure out how much they all own, or like collectively, without anyone revealing their balance. Could you go over that example real quick? Because I think that's the thing that made it click to me how MPC works and why this is so cool.
So I actually don't know the specific piggy bank example.
Okay, but you have a group of people, let's say 5 or 6 friends. They want to, they all have encrypted balances.
I usually, I also go about, what's the average of our salaries? That's also the go-to example I always explain. Yeah. But I explain it more in a technical way. Do you want me to explain it in a
try to keep it high level
way?
If we can, yeah.
Okay. So maybe you explain the piggy bank example,
sure.
How it works?
Yeah, so the piggy bank example that was so good that helped me click was basically if there, let's say, even if it's just Yannik and I have $10 in my bank account, Yannik has $20. We want to add those up to 30, but we don't want to reveal that I have 10 and he has 20. So what I could do is I could take my 10 and add a random number to it, let's say 7. So now it says 17 and I give it to Yannik. Yannik takes that 17 and then adds 20 plus a random number to it, let's say 1, so it's 21 plus 17, right? Those are 38. And then the final number, 38, then just needs to have our secret subtracted from it.
Yeah. Which essentially in that example would mean we create this piggy bank, which is this random number, right? We add our money in, and at the end, we destroy the piggy bank.
Okay.
Which then, I mean, we don't know who put in how much money. With 2 people, it doesn't work, of course, right? But
if you had 3 or 4,
it would work. And the way it functions on a more technical level is essentially, again, with random numbers and randomness. And so if we have 3 parties, we have Dev, Yannik, and Becca, and each of us have a random, have a secret value, our wealth, our salary, whatever, and we want to compute the average of our salaries. What each of us is doing is each of us creates 3 random values, 1 for each of us 3 players. I keep 1 to myself, I give 1 to you, I give 1 to Becca. And then the only constraint in that system is that those random values all added back together needs to form my secret, right? And once everybody creates those random values, distributes them, keeps 1 to themselves, everyone again ends up with 3 values, but I don't learn anything from your values. So I can just take those 3 values, add them together, you do the same thing, Becca does the same thing, and then once we've added them together, there's again this random noise that is part of those values introduced to this entire sum. So we can at that point reveal them to the world, to each other, doesn't communicate any information, and these 3 final numbers we then again add together, divide by 3, and we now know the average without anyone ever having to share their salary. And so that's at its core how MPC works. And once we extend that from just adding values together to multiplications, add a lot of more cryptography and security authentication and whatever to it, we end up with something like Cerberus, where we can run arbitrary encrypted computations without having to share any information.
The really cool thing that you just brought up that I really liked was you need random numbers to make this work.
Yeah.
And random numbers are not a thing that we have access to in like a traditional blockchain, right? Random numbers traditionally are a very bad idea because we have deterministic compute.
Yeah.
And that in itself, just that simple fact, now you've opened up a whole design space that again doesn't have to do with privacy, doesn't necessarily have, but like because you have that kind of simple mechanism with MPC to do random numbers, we have a design space open.
Yeah.
And a lot of these little techniques and technologies just open these things up. So let's go into that next. We talked about healthcare. For crypto, we talk about dark pools and dark DeFi. Mm-hmm. Can you talk a little bit about what applications in dark pools and dark DeFi look like, what they mean, why they're helpful for people?
Yeah, so I started to call that entire ecosystem that we are trying to bring onto Solana encrypted capital markets, right?
Okay.
So which combines internet capital markets and encrypted computing, and for me really is the logical culmination of bringing in institutional finance onto Solana, because most of the daily trading activity within traditional finance is taking place within traditional confidential trading venues. And so we can build a far superior system on top of Solana that combines internet capital markets and encrypted computing into encrypted capital markets. Now, what I think this design space enables is applications ranging from stuff like confidential lending protocols all the way towards entirely encrypted order books, dark pools, crossing networks. So there's many different implementations, many different DeFi applications you can build in an encrypted way now, with varying levels of confidentiality, varying levels of privacy, right? Always tailored to the use case. And I think that's so interesting. And what's so powerful about this is that, again, something that we've seen on Solana's public shared state now at this point then emerges in encrypted shared state, which is that we can operate across all of those dark black boxes trading venues at once within a single encrypted computation. So you can do smart order routing in a fully encrypted confidential way. And that's something that within TradFi is not possible. Within TradFi, these kind of confidential trading venues literally are dark pools. So if I wanted to, in a confidential way, settle a large order, I take that, I split that and submit it to different trading venues with, I don't know what the liquidity is, I don't know anything about the toxicity, but now with encrypted computing that changes, because all of that can take place in this computation, which from the outside Nobody can see anything. No single computer in the world knows what's happening, but within this virtual encrypted computation, all of that can take place. And I think that's what's so powerful about it.
I love it, and I think really one of the really powerful things that I really made it all click for me is you get all of these benefits while still tapping into the liquidity of a public chain like Solana.
Yeah.
Right. Unlike launching a new L1 or having the bootstrap problem of bringing liquidity onto your new chain, because you guys are a network extension on top of Solana, you get to tap into that massive liquidity that already exists, that is trading in that public venue, and then just give them more tools out of the toolbox.
Yeah, exactly. And I think that's so important, right? Being able to switch between those two contexts, because it's both operating over shared state and doing so in a composable way. I think that's this huge unlock that Arcium together with Solana brings to the world.
Yeah, and that's one of the things we were so excited for at Seedplex when we were looking at Arcium, because that meant that we can, for institutional players that want to park positions in all these new companies or all these new venture DAOs, they can do so in a safe manner. Because previously they were like, well, I don't want my P&L public, I don't want my positions public, I'm parking $1 million, $5 million, whatever. And we were like, no, we have a solution to that now. We have Arcium. So that's been phenomenal.
That's amazing to hear. Yeah.
One other thing that really nerds type me is this expansion into private AI. Mm-hmm. And I don't hear too much of that when you guys talk to the crypto audiences, but I would love to learn more about how you're thinking about private AI and what kind of applications you're seeing there.
Yeah. So again, Arcium, we call it the encrypted supercomputer. So for me, it is my task is to build this encrypted execution engine that spans across the entire world, right? Across every sector, is being coordinated by Solana, right? Even if there's some very traditional player utilizing Arcium, all of that takes place in this decentralized network built on top of Arcium, on top of Solana. So in regards to encrypted AI, encrypted intelligence, I've called it at Solana Accelerate, I think. There's one partner company, I would say, very traditional, very well established, that is utilizing Arcium exactly for that. I still have to keep that confidential,
sure.
As Mr. CEO of Privacy likes to keep things.
Absolutely.
But there is a huge unlock in being able to run encrypted training and inference, and we're currently doing that for machine learning. And so in machine learning, being able to have data that sits in isolated silos using Arcium to train a machine learning model across everyone's data without seeing any single bit of information. And now the powerful aspect is that the model itself, the model weights, can again remain fully encrypted. So it's not even just, okay, we train and now everybody gets access to the model. No, the model itself remains encrypted. And the next step then, when someone wants to run an inference, they have again sensitive information that they use to get that inference. So nobody should see their information. Nobody sees the model. Yet with Arcium, they can access the model without actually accessing it, right? So they only get an encrypted output back. So that at the end of the day then is end-to-end encrypted machine learning, where the training data, the model in between, and the inference all are encrypted. And yet you get the output from being able to harvest the data without ever touching it.
That is absolutely mind-blowing. And I want to drill down on this because I think there's some pieces of this that people might skip over because they just don't understand. Mm-hmm. But let's say you're using the state-of-the-art models today. You're using ChatGPT, Claude, whatever. They're proprietary models. And the reason you can't put proprietary models in an open source way is because those companies want to make money off of it. But what you're saying is because all of this is encrypted and the model weights can stay encrypted, you could have companies create proprietary models, make money off of that inference if they wanted to charge for it, while users don't necessarily have to give their data up to the companies that made
100%.
That is a huge unlock.
And I think what's so powerful about all of that is that that's actually currently being built on top of Solana as well. So Crunch DAO, for example, are building something like this using Arcium on top of Solana. And yeah, I guess that's awesome. A new internet.
Yeah, that's awesome. I mean, that's been one of the biggest challenges
Yeah.
in AI, right? You want to use the state-of-the-art models, but you can't because now you're giving up your data to whoever's running the proprietary model. So you have to use the open source models, which are slightly less good. That's amazing. I'm very excited to play around with that. I do have a question, but when you're running all this inference and all these things, we're traditionally taught that you need advanced GPUs, you need server farms and stuff. How are you guys dealing with that problem?
So we are not running LLMs within Arcium. That would be out of scope. So I mean, what we did last year is we acquired our largest Web2 competitor, and what we got from them is, among other things, MPC protocol they've been working on for 8 years, which is the state-of-the-art AI-related MPC protocol. And what that enables you is to do inference and training in an encrypted way. Actually, our current protocol that is part of Arcium servers you can use for machine learning. We actually, within Arcus, our compiler that Solana developers use to add encrypted computing to their apps, there is an extension in there for machine learning inference. So you could, within your program, say, oh yeah, here are the encrypted model weights, do an inference and reveal the output, and based on this output, trade a token. I don't know. That's actually possible, and I think we never publicly shared that even in our docs, but it exists. So you can do stuff like that. I think what you're referring to with hardware and the cost of executing those things, that's entirely true. So I think that is currently unfeasible, and that's also not what we are going after.
Okay.
What we are going after really is having the most trustless and, while being an encrypted computing protocol, scalable computing protocol. And then for those AI-related tasks, it's especially about things like model weight aggregation. It is about machine learning because for a lot of machine learning tasks, the scope of things is far from training a general purpose large language model.
So it would be like specifically trained data sets and things like that.
Yes, but that's totally feasible and only possible with Arcium.
Gotcha. And then one of the things you mentioned, with things like model training or anything like that, you're obviously blowing past Solana's compute limit because Solana's compute limit is set so all validators can compute within a set time.
Yeah.
But Arcium allows another really exciting problem space, which is I want to have large amounts of compute, or at least compute larger than Solana, right? So I could run that even if I didn't want it to be confidential, but it just happens. It's just great benefit that it is.
Interesting, that's true, So Arcium doesn't run its computations on Solana, right?
It runs it on the
chain, within the Arcium network. That's interesting.
So how do you think about like fee structure or like payments for the Arcium nodes? Like, what is the Arcium network look like at a high level?
So I think what's important again for users and developers, if someone is building an application and within their on-chain program they say this function should be encrypted, which then means that Arcium is processing that, there isn't that the user doesn't notice that at the end of the day. So it's not like, oh, I now need to pay with some additional token for the computation. No, you just pay like you pay any transaction with a Solana fee, right? And then a portion of that, of course, gets distributed to the Arcium network for running these computations. Yeah. So
what does the Arcium network? If I wanted to join the Arcium network, are there requirements? Are there if there are Solana node operators or RPC providers, like, does the Arcium network have RPCs? Like, what is the Arcium network?
So we are going to launch our mainnet alpha this quarter, and at that point on, developers will be able to utilize Arcium directly on Solana mainnet. Our network itself will be in mainnet alpha. And what that means is that it is going to be, at that point, a permissioned validator set.
Okay.
And then we'll have that running for a few months, doing more optimizations until we'll have mainnet beta, which then will have fully permissionless node operations. So now in this initial phase, we have a lot of Solana validators also running Arcium nodes.
Gotcha.
And also other third-party node operators. So at the end of the day, it's the same as with Solana, but anyone can run a node. So with Arcium, the requirements are very low. I would say. So when we did our benchmarks, our latest benchmarks against fully homomorphic encryption, we were running the FHE operations on the most expensive hardware you could have on H100 clusters, right? Because that's what this kind of FHE needs. And Arcium, on the same hand, we just ran on I don't know the specific AMD processors, but it was 24 cores, right? 24 cores, 128 gigabytes of RAM. Nothing impressive. Sets you back maybe $100 per month. And that in a decentralized computation amongst these kinds of nodes. And there we even with this kind of hardware, right? Before Arcium even did any hardware optimization, we are more than 16,000 times faster, and it's only accelerating from this point forward. And so we don't really have strict hardware requirements right now. I mean, down the line, if we want to have more optimizations, we can have that, but I think the way Arcium is designed is that node operators can actually specialize for different tasks. So if there is at some point, let's say, a more specific machine learning backend that has to utilize a custom CUDA implementation on top of NVIDIA GPUs. Some node operators might run this kind of hardware, while others run on more or less a Raspberry Pi, right?
Yeah.
I think we will want to do a lot more hardware acceleration and optimization. So there will definitely be some lower bound of hardware capability you need to have, because the whole point behind Arcium is be as fast as possible while being trustless. But yeah, in general, we don't rely on that too much.
But the interesting thing that I was so excited by is you don't require them to be TEs.
Yeah.
You don't need specialized trusted execution environments. Anyone could run a node if they had the proper hardware.
100%. Yeah.
And that's awesome, because most of the time when we talk about encrypted computing or things like this, we talk about TE networks.
Yeah.
Which, I don't have access to a TE, but I could buy the hardware to run an Arcium node.
Yes. I mean, you could in a TE network buy a TE and then you.
But then I have to secure the TE with physical security.
You would have access to whatever data you're processing, which sort of defeats the point in my mind. And that's why our approach instead of trusting Intel and AMD, trust mathematics. That's at the end of the day what
Love
we're
that.
doing. Yeah.
Love trusting mathematics. That's what we're here for in crypto. With that trust assumption, there are two terms that I really liked in your docs, which was dishonest majority and honest majority, right? And one of the things that nerd sniped me was this concept that normally in blockchains you need the honest majority, which is most nodes have to be honest or doing things correctly. But in Arcium's case, we can have a dishonest majority. Can you explain a little bit more about that?
Yeah. And so we define honesty as behaving according to protocol or trying to exfiltrate secrets, right? That's this main concern that we are thinking about. How can we secure data? How can we process over information without ever seeing it? And so we need to ensure that there's no party in this network who could ever get access to that data. Now, with secure multi-party computation and the way secure multi-party computation is used in also all FHE networks and implementations, is operating in honest majority, which means if we say we have 100 nodes that run a computation, at least 51 of those nodes need to behave honestly. So you need to ensure that there's always a set of 51 nodes that don't try to maliciously collaborate, basically be a Sybil, right? And attack the network by trying to exfiltrate the secret. And that is difficult, and it makes your protocol not really trustless and requires you to use an enormous set of nodes, which comes with its own problems. And so we, from the get-go, decided that Arcium needs to operate in the lowest possible trust assumption, which is dishonest majority, which means out of an arbitrarily large set of participants, there always only needs to be one single honest one out of n. And that's so powerful because if it's designed in a permissionless way, Dev can decide to become a node and have zero trust because you can ensure that you behave honestly. And yeah, the way it functions and why we are able to do that and why our Cerberus MPC protocol is the first ever practical dishonest majority protocol in the world is because we overcame one of the big limitations of it, which is that in the past it was more of a theoretical thing, with the big limitation in practice that a malicious party, which isn't malicious under the assumption of trying to exfiltrate a secret, but malicious under the assumption of trying to stop a computation from taking place, DDoSing a computation, essentially censoring, right? We solved the censorship problem in that regard by implementing the first ever implementation of an identifiable abort protocol with cryptographic cheater identification. So we can cryptographically identify this kind of misbehavior and disincentivize that.
That's awesome. Like all of these things that I'm hearing from you are like pushing the boundaries of what I thought was possible when we think about blockchains, right? Like this is so exciting. And the best part about this as a developer is this is not theoretical. This is something like as I've been writing code in Arcium, I'm like, wait, the DevX is also really good. Like I can actually I can work in this environment. I don't have to write, like, you know, when I started getting into ZK back in the day, I was writing circuits by hand, you know, and now Arcium just compiles my circuits from Rust code. What? So you made the math possible and you made the programming
within
possible.
1 year, yeah.
That's amazing. Like kudos to you guys.
Thank you so much.
That is amazing, and thank you.
No, that's great to hear from a developer, and it means a lot. Because at the end of the day, right, it doesn't just boil down to the underlying technology. It boils down to also making it accessible. So all of those things need to match. And I think we still can push that way further, make things way simpler. Yeah, I'm super happy to hear that.
So one of the DevX experiences that you guys are working on improving is this confidential SPL program.
Yes.
Can you talk a little bit about what that is and how that improves the DevX for confidential tokens?
Yeah. So basically, Solana has, with the SPL token 2022, token extensions, and one of which is the confidential transfer extension, which is bulletproof ZK based, where you can, in a confidential way, send tokens from one token account to another, and if the token is supported, if it's a special token with confidential extension. And that has been something that has, I guess, within the entire developer ecosystem and user ecosystem in the Solana space, sort of been this meme, overpromised meme of something that currently isn't live on mainnet and hasn't really been used by anyone because of a lot of issues associated with it.
It was technically possible, but the DevX was so bad no one wanted to use it.
So there's two aspects to that.
Okay.
You could technically use it, right, with a bad developer experience, which is fine, I guess. At the end of the day, if you really wanted to use it, you could use it. The bigger problem is that it's incredibly limited. So when you think about confidential transfers, you think about your token simply being confidential and you're using smart contracts and stuff. That was not possible with that. All you can do with that system is send from one wallet to another wallet, from an EOA wallet to another EOA wallet. And so what we've been doing with CSPL is building a wrapper around all of this. So I really like the cryptography that the Solana team has been building for this. And we use Arcium to wrap around it, make it accessible, and make it 10 times more powerful. What I mean with making it 10 times more powerful is overcoming all of the key usability issues. One of which is that for the first time ever, an on-chain program can now manage confidential token balances. Previously, it was only wallets, right? I could use my Soulflare wallet
like user
and send
wallets,
you something, right?
user wallets, but not smart contracts.
Exactly. So user wallets, right? Which doesn't just limit the use cases to just payments, I guess, but it also had things like I couldn't send you a token if you hadn't previously created a token account for that token, which is insane and never happened. So it's literally impossible for me to send something. Arcium takes care of that. Thanks to Arcium, it is possible to do that. Only thanks to our technology, it's possible to do that. And the big unlock really is having on-chain confidential token accounts within programs. So you can't just go out and say, okay, I want to build this private payroll program that creates token accounts and a user specifies how much salary someone gets, submits that as an encrypted value, and then the program performs a confidential transfer to that user. Nothing is seen. The developer doesn't have to implement anything that they wouldn't have implemented in a public transfer system, but now they can simply make it confidential. And that's what people always wanted, and that's what we can bring with our technology. And that's only possible with encrypted computing. And it goes beyond that. We also now have confidential token wrapping, so I can just say, okay, I have USDZ, I want to have confidential USDZ. So there's a canonical confidential representation that turns your public token into a confidential token. And all of those things combined are CSPL, the most simple interface you could imagine, more or less the same interface as with public SPL tokens, being able to switch between standards and allowing on-chain programs to manage confidential token accounts and perform confidential transfers. And that then really forms the basis of encrypted capital markets.
Taking, again, that high level of math and then making it approachable for people like me to actually make use of and
exactly
use
right. That's the task that I and the Arcium team and my PhDs have, is to do all of that work so that people with blue hair can be creative, right?
And we appreciate that. The people in blue hair appreciate that quite a bit. You know, I know that Ariant and Nico have heard tons of my questions every day as I run through things. Okay, so as we wrap up, I just have a couple of final thoughts. You know, the people watching this, whether they're developers, not developers, anybody interested in learning about Arcium, where can they learn about Arcium, and what are the ways in which they can start getting involved, and what's kind of your roadmap going in the next couple months?
Yeah, so docs.arcium.com, ARCIUM, and also our Discord, and we are starting a sort of incubation program, I guess. So if you're really serious about something you want to build in privacy and you want hands-on support from us, like we've done together with Umbra, right? We've incubated Umbra from day one, and so if you want to have this level of support, we are more than happy to support you. And in any case, you can also always DM me on Twitter or any other team member, and we are more than willing to always help you build stuff, and we're always happy to get any feedback and improve stuff. And it's been amazing to see how now that we are moving closer and closer towards our mainnet alpha launch, the amount of teams, now also with the Colosseum Cypherpunk Hackathon, where Arcium is sponsoring the DeFi track, are building more and more use cases, making use of encrypted computing. And Solana is the first blockchain where that's actually possible. There are so many, I don't know, blockchains that claim to have privacy, but none of these blockchains actually come close from to the amount of people building with privacy, because Solana now with Arcium has the most powerful privacy in the world. One
of the best network extensions, right? Because you have all the public liquidity of the Solana blockchain, the public developer ecosystem of the Solana blockchain, but now you have just given them a massive amount of tools and be like, here's a new design space, here's an entirely new way to work and think and do all these things. And it's like discovering blockchains all over again. You know, it's that I get to be a kid again moment. Cool. Last question to leave you with. What are you personally the most excited for Arcium in the next year?
Within the next year, I am most excited about launching both mainnet alpha, mainnet beta, and seeing all of those applications that are currently being built and are going to be built over the next months go live on Solana mainnet, and bring a whole new set of users on chain. I think that will accelerate the adoption of, I think that's the way I think about Arcium, right? We're this purple fuel that basically accelerates and bringing more adoption towards Solana, because we enable more powerful applications. So I'm super excited to finally be able to see that unfold on mainnet.
Awesome. If you are excited about learning more, docs.arcium.com. They're phenomenally written. They have a great blog. You can bother all of their team members. And then also, I will be doing a bunch of content on Arcium coming up on my page. You can follow me on Twitter at SpacemanDev. because I love them so much. And as I learned, I want everyone else to learn too. And hopefully we can build this encrypted, what were the terms you use? Encrypted capital markets?
Encrypted capital markets.
Let's bring encrypted capital markets to Solana. All right. Thank you so much, Yannik, for chatting with me
having me,
today.
Dev.
Absolutely.